Hello everyone, Giacomo Lozito. I had the application operation function at Wood Mackenzie. This fine morning, I'm here to talk with you about stealing fire from the Olympus, a Prometheus journey. Prometheus is a monitoring system. Most importantly, for us it was an interesting IT project that we started in January this year. And we had to learn a lot of lessons, sometimes hard lessons. We got a lot of insight, not just from the monitoring, but how monitoring itself is not just yet another IT operation project. It's something that requires the whole business to work together, certainly the whole technology department. And the way you monitor things really depends at what point you start thinking in your application about monitoring. So why did we bother? It's not just because Prometheus is really cool, as we'll see in a minute, but mostly because we had a number of good reasons to do that. Before I go to them, make a full disclaimer that most of these slides have been altered during a flight between Edinburgh and New York. So if you feel that anything is confusing or anything like that, I blame the altitude and the lack of oxygen. So what did we find was that we had multiple environments on-premise, AWS, Azure, and we had a lot of different applications that resulted ultimately in the production of different metrics, inconsistent between each other, so difficult sometimes to cross together to understand what was going on into a distributed system. Obviously, every monitoring strategy that we had in place was designed with its own view of the world in mind. So you would have one application that cared about maybe the login, and then you would have another application that was monitored in a different way, that was taking care of the backend processes. Alerting strategy, that's an interesting one. Well, mostly was handmade and crafted because some guy wanted to know when something was happening. Not because we had the proper orchestration or the proper idea of how the teams should have been escalating and operating together around something going wrong in the environment. What would have been a trivial root cause analysis many times resulted in people hopping around from one server to another to find out what was going on. So this is a classic scenario, and anyone that has been in a business that has been around for more than a few years can probably relate with this. It's not like an application gets designed from the beginning with the idea of having a front end in AWS monitored by cloud tools, which then connects to a very classical user API that is monitored by an APM service online, a third party. And then you have a session manager, which is in the data center and probably monitored by conventional data center tools. And finally, you have a user directory, which is ancient, and maybe only a few sysadmins in the company have the courage of go there and touch it. So unless someone really hates you, they are not going to sign this from the beginning, but this is what you actually end up with after years of operation, and pretty sure many people can relate with that. So the reason to take a monitoring project for us was really to try and address the lack of consistency and the lack of a big picture vision around the applications overall, third parties, on-prem, in the cloud, altogether. Provide a consistent view around our entire product landscape. Provide instrumentation to track both application level and operational metrics alike. We don't just want to see the CPU and RAM issues. We also want to see the metrics that the application cares for. And depending on the application, they could be dramatically different. It could be logins per second. It could be database queries. It could be anything. We designed the alerting strategy on top of this new instrumentation, consolidated, because when you finally have a consistent view of the world, then that is where you can put some alerting in place that finally makes sense. And this was very much designed into a DevOps fashion, so promote an open environment where the whole technology team could operate and contribute, rather than having monitoring on top of a finished product, GIF wrap in the end, which usually is too late. So what is this Prometheus? For those that don't know already, Prometheus is, at its core, a time series database. So if we record metrics that vary over time. It doesn't matter what kind of metrics we're talking about. It's not necessarily operational metric. It could be anything. It could be the level of moisture in your home plants at home. You could use for that. I do. You could monitor KPIs. You could monitor anything. You just need to know what Prometheus is good at and what is not good at. And hopefully that's what you will be able to take away today as well. So the server uses a pull model, and it collects the data from agents installed on the machines. Agents are really called exporter, because what they actually do is export the data in some format, and the data that is exported is metrics. Push gateway is a different solution for things that are so locked down or that don't necessarily run every time, so that if you have an asynchronous batch process that only runs every so often, you can decide to actually have the opposite strategy there of actually pushing into the push gateway that then will be pulled by Prometheus. Finally, you have a web UI. It could be anything. Grafana is usually the preferred one used in combination. That's what we decided to use as well. This is what the Prometheus metrics look like. So the moment we contact an endpoint, and that happens to an HTTP request, you actually get a simple, readable, human-readable text format. Now, the thing that matters there is that there is a metric name, and then you have labels. Those labels actually allow you to categorize that metric per CPU, per system, per anything. Also, the labels are arbitrary, so you can use whatever makes sense to you in order to categorize that metric. It could be even the application name into one of those labels if you want. It is worth remembering that the metrics names can change based on the exporter. This is something we'll come back later, and it's super important to understand, and it's something that we probably underestimated in the beginning. If you're using a Windows exporter, which is based on WMI, you're going to get CPU and RAM, basically, at the basic level, called with a different name compared to the Node exporter in Linux. So ultimately, why did we choose Prometheus? What was so good for us? The killer feature for us was service discovery. This is the one thing Prometheus is really good at. With Prometheus, you don't want to go into the details of micromanaging the servers that are target. You just want to provide it one of the many ways that it can actually find what it needs to monitor. And again, like I said, the nature of the metric is completely arbitrary, and that is something we like because we wanted to monitor metrics. And the key thing is, we were designing a new application, we always are, and we don't really know from the beginning what kind of metrics are going to matter for that product. So we need something flexible that will collect whatever is thrown at it. So that's why it was most important for us. Open source is a huge value for us because it means that we can look into the code ourselves and make a change where it makes sense. And finally, it is very flexible to set up. You can afford to make mistakes in the beginning, which I think we did, because it is not one of those things that you can't scale up or, more importantly, scale horizontally later if you want to. So just go with it. Don't try to make it perfect from the beginning. Not going to happen anyway. So what Prometheus it is not. You don't want to choose Prometheus, as we found out, if you're looking to track trends over a very long period of time. It's not what it is designed for. The standard data retention time is actually 15 days. So Prometheus is really targeted around the here and now. You want to see what's going on. You maybe want to see what has been going on yesterday and 1 week ago. You don't want to go beyond that. So you will probably need to think about how do we complement Prometheus with some sort of longer-term retention tool to make sure that you have the long-term picture, which is equally important. It is not a turnkey solution. You need to be prepared to build internal expertise to actually maintain it. It is not something that you just start to use and it just works. Well, it does to a point, but the thing is, there's always a different assumption from different people, from different groups, on what they already know about monitoring. So there is a learning curve. It is not Nagios and the others, and I actually would recommend to complement it with that because it is about numerical trends. It is not about state changes. It can do that for you, sure. So you can have an example, the system being up and down, it's gonna give you a matrix 0, 1, fine. But if you are really looking to run custom scripts that will check for a certain situation and will give you a state as a result, rather than a number, that's not what you should be using Prometheus for. And finally, it is not a solution in itself. Well, not technology tool really is. The reality is that you put something in place because you have a business need, and technology is a mean to that end. So Prometheus should be part of a big picture view that you have. So you're centralizing the metrics that way. You probably want to do the same around the logs at some point. You want to have those state change monitors as well. Just don't be idealistic into thinking that just because you chose Prometheus, you need to do everything with it. That's not a requirement. Nobody is compelling you to do that. From a deployment perspective, this is what we decided to do. Prometheus and Grafana can run in containers. So at the very simplest level, and you can do this in your workstation in 5 minutes after you're out of here, just Docker pull those 3 containers, and you can run them into a stack. Why containers? Well, like I said before, we have on-prem data centers, we have AWS, we have Azure. So ultimately, we want to make sure that we can deploy the same solution into a lot of different environments without having to think too much about it. And containers give us that level of portability. If one day we want to go Kubernetes, we'll be set already for whatever reason. Why bin mounts and Docker, not Docker volumes? That might be an interesting one for people that already are comfortable with Docker. We will explain that in a minute. It's because of what we decided to do in ECS in the cloud. That is where we had to make an interesting decision. We obviously want the data, the monitoring data, to persist. And if you just run a container, when the container goes down, you're going to lose that data unless you put that into a bind mine or into a Docker volume. So we had 3 options, really. One of them was just the local storage on the underlying EC2 instance for ECS. But the problem is, if that EC2 instance goes down, you lose everything away. You will need to back up that data, which might also mean that you might only retain as many metrics as how frequent you do the backup, which might not be optimal. The other option is EBS storage, which is certainly easy to snapshot, and it can survive EC2 instant termination. The one thing to be aware of, obviously, most of you people in the room probably are, is that EBS volumes are tied to a single availability zone. So if you are trying to make your monitoring system SA, this might not be necessarily the best way to go, although you can do it, as you will see in a minute. EFS storage, that's nice, that's multi-8Z. However, it's got no snapshot feature. It's honestly a pain to back up because you need to mount it somewhere. I'm sure AWS will end up addressing that at some point. They just haven't done that yet. We would have considered Docker volumes if we were starting the project today, because just in August 2018, ECS actually introduced support for Docker volumes directly baked by local storage EBS or EFS. So you can do that now. You can use Docker volumes, and you can comfortably tie with EBS. Unfortunately, we are already out there. At some point, we might decide to migrate the metrics. The thing is, obviously, we don't want to use something that has been just released, because that's going to be a lot of fun. Rollout strategy. So how do we bring Prometheus in the cloud? And obviously, most of what I'm going to say really applies to any environment with the proper differentials, but it's mostly there. First off, you will want to have a stack that deploys the persistent data. You don't want to have a Unix stack that deploys both the persistent data and the Prometheus stack that you're going to roll back and forward, because that might actually result in you losing the EBS volume. You can keep that separate, and you can also make sure that that contains a backup strategy of some sort, as you can see here. And you can even use something like the lithium polish you retain to make sure that even in the accidental situation of a stack rollback, you will not end up losing that EBS volume. Sure, it's going to be a snapshot. Probably you're copying the data somewhere else, but why take that risk if you can avoid it? ECS, the cluster itself, I guess the only really important thing to say here is that obviously this stack, which is not fully here for lack of space, is the stack that we reference the EBS volumes created into the first stack and were mounted automatically. And most importantly, it provides a very important Lambda function that we will talk about in a minute to do proper service discovery in AWS with ECS. From a configuration standpoint, these are the rules that we gave ourselves. We manage everything as code. We don't go on Prometheus and make a manual change. No, do that. Don't do that. It will just create technical debt over time. On-prem, we drive the configuration deployment with Ansible. In AWS, we deploy that config in an S3 bucket. In both cases, we actually use a Jinja template, so the differences between the environments are minimal because the configuration is coming up pretty much in the same way. We invested time as early as possible to ensure that Active Directory or LDAP integration to login in Prometheus will be there. And the reason is that we wanted to allow everyone into the new monitoring system from day one. We don't want to develop this on the top of a mountain, then suddenly come down like messiahs and say, we have done, this is your monitoring system now. That prevents feedback, that prevents people from having participated and having given you very valuable input that you could have had if only you had the load into the monitoring system in the beginning. In all cases, we rely on DNS to discover our monitoring targets. In the beginning, we actually were generating the inventory using the Ansible one, but that came with a very big shortcoming that we realized very soon, that in your Ansible inventory, you actually probably have your servers, but what you really should be monitoring are your services. So how do we provide people the ability to do whatever they want in Prometheus? And by people, I mean technology, I mean developers, I mean operation, people working together in the same group without the monitoring system going down, or how do we allow mistakes? What we did was to make sure we had two different Prometheus stacks in dev, one per region. So basically, we have a dev stack for Prometheus. And this one is accessible to everyone. Everyone can make changes. Everyone can go there and assign their Grafana visualization dashboards. And if we ever want to combine the metrics coming from one region to another, Prometheus has got a federation feature that will basically use one of the Prometheus servers as the pillar for the other, just like it was another agent, which is really convenient. We didn't have to do that, to be fair, because we tend not to have too many cross-region applications, but we can if we need. Why it is so important that people can go there and design their own dashboard? Because if people are developing a product, you are not necessarily going to be involved personally into everything that's being designed. Into every product, there's going to be different metrics that matter again. And you want to make sure those people have a capability of pushing out those and having them pulled by Prometheus and visualizing what matters to them. They should be allowed to create their own visualization and make sure that they have a view that is consistent to them and that can be integrated with a larger view of the world. Then we have a tooling one as well, which contains the production Prometheus. And the production Prometheus is still accessible to everyone because there's no reason to hide the monitoring metrics, but we only allow changes to a certain theme that is basically just driving the automation from the theme visualization in Grafana extracted from the development one into the production one when people say they're ready. You can extract your Grafana visualization as code, and so they can be versioned, so that then you also have a way to keep track of what's changing in your environment, how the visualizations are evolving. So, like I said, for this project, we took a minimum viable approach, so definitely not making people until we make it perfect. It's never going to happen anyway. Frequent, small rollouts across all of the different environments. If something is not working okay, you want to discover that sooner. You want to make sure that that change gives you a feedback. You don't want to make monolithic pull requests, which, by the way, are a pain to review, and suddenly bring in so many changes, and you don't know what exactly changes the behavior of the system. Again, giving access to the tools is so important. And finally, keep the product usable at every iteration. Never say, and unfortunately, I'm pretty sure many people have heard that, it's not production, doesn't matter if it works. If the dev doesn't work or the test doesn't work as expected, why do you believe production is going to be any different at some point? Service discovery, very important bit for us in order to make sure that we would discover what to monitor and at the same time understand what we were looking at. you don't want to end up in a situation where you have a dashboard. So in this example here, we have a CPU spike, 80% at some point. So sounds pretty important, but they're just IP addresses. So unless, those people are around, you have sysadmins in your company that have memorized the IP address of every single server. I used to be one of them, to be fair. But unless you have those people, and please don't, the information is there. You just need to make sure that you are visualizing it. You want to give people names. You want the new hire coming today in your office to look at that dashboard and understand what's going on, or at least have enough context to figure out the rest. You don't want that person going around and asking, is that mission important? What if IP addresses changes over time, by the way? Your monitoring becomes even more inconsistent. So bad practice start at development stage, which, by the way, is not to say they start from developers. Development stage is something that operations should be equally involved from the very beginning. If you don't do that, you can complain later. And if we don't provide a DNS server to the development teams in the beginning, since the dev environment, so everyone complains around IP addresses having put into the configuration, maybe even in the code. But if there is not a DNS server for the test and the dev environment, why should production become any different later? If there is one thing that you feel you don't have at the moment in your environment's landscape for non-production environment, and that thing is DNS, fix that. Make sure that's the one thing you do before you go into a monitoring project, a continuous integration and deployment project, log centralization project. You need names. To us, it was very important to do this because we have, again, that on-prem and AWS difference. So we couldn't really choose to use the EC2 service discovery that Prometheus provides, simply because it wouldn't have covered the on-prem data center. So we went with the one thing that we knew would work for everything. DNS has been around for, the SRV records in DNS has been around for 20 years now almost, so they must be solid. And in fact, they actually work and they do the job done. So the two more requirements to make DNS functional for our service discovery purpose. The first one, you want to use something that is API driven in AWS, Route 53 obviously. If you are on-prem, you can use something like Power DNS, or you can find another DNS server that basically provides you an API to make changes. You just want to make sure you know that the automation can be driven. And finally, again, if your company has been around for enough time, you probably have a DNS management system into some third party somewhere managed by sysadmins that will not let anyone near it. And obviously, just flag it, because that probably contains the names that are used in the main application and the client-facing one. But at the same time, what you really should be doing is using zone delegation and make sure that all of the different environments have their own little word, and the names can just be registered under that one. So a new service is coming up in environment 01 or in the test environment, just use that into that subzone that can be delegated to Route 53 or for whatever your automated system are. Put that in place. So the thing we're actually looking at in the previous slide, that was a Jenkins node, but suddenly if I have a Jenkins node or one tester1rootmap.com into that dashboard, it makes a lot more sense on what's going on, does it? So, again, for monitoring, think services, not servers. Services are really what you want to monitor. Servers could go down as well. Maybe you want to be aware of that, but ultimately what you really care about is the service you're offering to your client and the fact that that's healthy and staying online. And when you are registering the records into the DNS, you actually want to register services. So node exporter, which is the agent that provides you the basic metrics, CPU, RAM, disk usage, it's actually a service running on each one of those services. And so what you can do is to just create a single record called metrics, node exporter, envo1, whatever you want, and populate that with different targets, one for every machine that has got that service. So when a new machine comes up, it's just a case of registering into that same SRV record, and then suddenly Prometheus is monitoring 5 servers for you, no longer 4. One service is gone because, not because it's gone down, but because it's no longer used, is removed from the record. And this is very important because you need to make sure you understand the difference between a system that is gone from a system that is gone down. Especially in AWS, where you maybe will have something spun up, running for 5 hours and then disappearing. You need that kind of dynamicity. Monitoring services, I will quickly go through that. General principle behind automated SRV record management. So this is what we're doing in the cloud. You could basically translate that into something else, into on-prem, but it would be the same. So you have something being deployed, CloudTrail event that triggers a Lambda function that will write the SRV record. In the beginning, what we tried to do was tell all of the application designers, can you please register your application to the DNS server? But then we realized that that wasn't a great approach because what was happening is that people maybe were spending more time figuring out how to do that rather than writing a simple service. Or maybe we would have to provide more permission that required to that application just because it had to access Route 53. So we actually decided to make sure that our service discovery would work from outside the application using Lambda. And we tried to figure out the events that were most suitable for this purpose. And we decided to go with tagging. So the way we did this is basically by having a tag pattern established in the organizations that people should use when they tag their containers or their EC2 instances. Anything under that pattern gets automatically interpreted in such a way that Lambda creates a corresponding SRV record and starts monitoring things for you. So we transformed things from having people having to register their own service to the DNS server to people having to tag things in a certain way that they should still already be doing anyway for compliance, and you get your system monitored for free. This is a sample of the CloudWatch rules that would be triggered, and then there would be this is a pseudocode showing how the Lambda handler would take care of that. It would basically retrieve the IP address, maybe create an A record for that IP address as well. That's important, and it's missing there. We would also lock the table in Dynamo, because if you have a lot of service coming up and down, you may have a race condition where you suddenly introduce a record while another is being removed. You may lose something. So you need some sort of lock-in mechanic. You can use Dynamo to just write a record, have a placeholder there, and use a proper lock-in mechanic. From an improvement perspective, like I said, yeah, we were creating SRV records this way. We also started creating A records because we want the names. And we made that pattern more and more articulate in a way that will support multiple ports, multiple names, so that then people could basically just say, okay, I have a service which is running port 9100, and then another port for the JMX exporter, and then another port for C-Advisor if you're running containers. How do you monitor all that? Just with a single tag, you get everything for free. This is an example of our ECS cluster layout, and pretty much the same story. The only important difference is that in ECS, obviously, you want to monitor separate containers within the same EC2 instance, so you can no longer use tagging associated with the EC2 instance. What you will rather want to do is use Docker labels that can basically tag for you individual containers. And again, we go with the same principle. You record that into your DNS server, and suddenly you have the same mechanic working for containers. And obviously, we need to take care of removing that information as well. This is really the summary of what I described so far: what happened, CloudTrail, CloudWatch, and finally Lambda, writing something Route 53, locking in Dynamo. Serverless is another interesting one. We neglected it in the beginning. With serverless, our idea was, okay, let's have people expose metrics directly into the API gateway endpoints. That only works for very complex services. What if you really only want to monitor the outcome of Lambda function? You don't want to reinvent the wheel there, because the data is already there in CloudWatch. What you want is to make sure that data is visible, so there's a CloudWatch exporter. And the important thing there is that you are not having people go and look into CloudWatch, which again will put us into the initial problem of people looking at a small view of the world. You actually want that data to come out into your central monitoring system, so that then you can coordinate metrics consistently. On the alerting, the only thing that is important to know is that you will have different metrics with different names from different exporters, but you can reconcile that using recording rules, and that's what we had to do. So we made sure that our recording rules will basically show you the same name, disk-space usage, irrespective of what the underlying metric for Windows or Linux will look like. So effectively, what we do is monitor and alert on that. Those are examples of all the monitoring metrics. And Alert Manager is the tool of choice for Prometheus in order to make sure that you can decouple alerts, like what Martin was saying in the presentation before. You want your alerts decoupled, you want your alerts to matter, you don't want alerts to be ignored. And those are the strategy tips that I just mentioned. And finally, to close everything down, Prometheus is now used in all of our production environment. We have not solved every single problem. We are very much on this journey. What we will need to do better is understand how to make people more comfortable with that knowledge, make sure that everyone is on board with what we are doing, document the way of doing Grafana and PromMQL to create complex queries. And at the moment, the definition of alerts is very much still an offside task. But we are quite pleased with the level of big picture view that we have now got. And I think that's going to be very helpful to drive our view of the world further. That's everything. Thank you, everyone.